quick flashcard poll here at the beginning, just to, again, this is kind of for me to gauge how familiar people are with the topic we're going to cover today. And then we are going to dive into the lecture content and get started building a circuit. The course is called Mechatronics. It's an area kind of at the intersection of mechanical and electrical engineering. So we're looking at not just circuits, but circuits that interact with the physical world using sensors and motors. So lots of things inside appliances and devices that we use every day. Students get their own individual circuit kit for the class that they get to take home with them, and they can use it on homework assignments and in lecture activities. The circuit kits really make sure that every student in the course gets to do all of the things and experience all of the equipment in the course. So we are starting the first half of the semester with an individual project where students get to pick what they do. We have a student who made a little sign that flips out to remind people to take their shoes off coming into her apartment. Other things like contactless doorknob opening, that sort of thing. It's interesting, again, when you give students that kind of creativity and choice what they pick to do, they get to work in teams for the second half of the semester as well. So hopefully, having gone through that individual project first and everybody kind of having the different experience and skills, then the robot project will be a little easier for them to do this time.
There's 4 milestones you have to complete. The first one was being able to drive around in a square. So we were able to complete that the first day in lab, and then we also went ahead and made our design proposal as well. So we had a 5-minute presentation talking about what our strategy was going to look like and some of the sensors we were going to use. And right now we're working on using the color sensors to be able to test and detect the 2 sides of the board, as well as detect the black line and be able to drive back and forth between the 2 colors. And then after that is the final milestone where we will be collecting 5 blocks on a mock board. And so it's basically to see, can your robot really collect the cubes? It's been going well so far. Right now we're testing and debugging our color sensors and our algorithm.
For milestone 3, you have to actually take data from all of the sensors you put on the robot and write an algorithm to figure out what to do with that data. And that's proving to be, it's just a lot more code to write and to deal with and debug.
Balancing hardware and software is very difficult, because in the first challenge we were pretty sure if something wasn't working, it was a software problem, but now it's it could also be a hardware problem. So isolating where the problem is something that we're learning while we're doing milestone 3.
So we'll try again, then if it works, yay! I have a burrito.
You're fine, sir. You're fine.
Wait, you did so well the first time.
I wonder if it's stuck in a loop somewhere.
That's really what real engineering is all about, right? When we're out there designing spacecraft or cars or whatever the devices are, it's not just something where the final answer is X equals 2. So this is where students kind of start to get that taste of tackling a much more open-ended project and dealing with those constraints, and something where you do have a final deliverable, but there isn't necessarily a yes, this is right, or no, that's wrong. Hopefully it sort of demystifies how all of these things that just kind of surround us that we take for granted every day, how they actually work. And as a professional engineer in the future, it makes you more confident that you could actually design and build something like that yourself.
This is a test, so it may not work. What is it doing?
Historically, this class has always ended in a robot competition that I like to describe as Battlebots, but less violent. So it involves robots kind of competing in an arena, but the goal isn't necessarily to destroy the other robot. That is always a big tournament on the last day of class. It's a big event for the department.
Yeah, you guys ready? I'm ready. Are you ready? Ready?
Pushing the robot out of the arena.
Start in 3, 2, 1, go.
Go, 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 go,
Having the competition just brings to light all of the things that you don't expect to happen. So we weren't I didn't expect that sometimes we had a couple instances where the arm didn't come all the way down, and that almost never happened when we were practicing. But that's because in practice it's perfect. It just kind of makes you go back and look at your design and evaluate things you didn't think would happen.
So there are a variety of skills that we hope students will walk away with from this course. Some of that is the more kind of traditional paper and pencil, doing the math and the physics behind the circuits, but there are also a lot of very applied, hands-on, hardware-oriented skills in terms of physically building these circuits, debugging them and troubleshooting them when things don't go right, programming a microcontroller to interface with the circuit, and then ultimately building some sort of mechanical or structure, because again, we have this overlap with mechanical engineering and we want to build a device that interacts with the physical world.